Assalamu alaikum everyone. Today we will start the topic moments of forces. Actually, this topic is a subtopic of the topic equilibrium of a rigid body. That is a major topic of further mechanics. In this topic, we will study moments of forces and then we'll go to center of mass and then combination of these two. So today's class is on moments of forces, and this is our lecture number 1. So in this lecture, we would start to understand some words. Whenever you will see these sentences or phrases in the question, you will understand that it means something special. That means how have you used these modeling assumptions in your sum? Like if we model a plank or beam as rod, that means how have you used this modeling assumption in the sum? When we model those as rod, it means it is one-dimensional. That means its width and depth are very, very negligible compared to its length. Now, if we model a plank as a uniform rod, that means the weight acts at the midpoint. That means the weight acts at the midpoint. Similarly, if we say that we model the plank as a light rod, that means you have to understand that we are not considering the weight of that rod. The weight is negligible. So these are some important phrases that we should keep up in our mind while solving the sums. So let us start with the definition of moments. What do we understand by moment? Actually, moments give turning effect. Now, if you can see a force and a point in the screen, this is a force and this is a point. We can say that this is the pivot point or the reference point here. Now, if you were asked to find MA means moment about A. If you were asked to find moment about A, that means you have to multiply the force F and D. F into D. F into D. Now, this D is the most mysterious here. Students often struggle with this D. Now, what is this D? This D is a perpendicular drawn from the reference point on the line of action of the force. I repeat, this is the perpendicular drawn from the reference point on the line of action of the force. Here you can see that this is a reference point and we are drawing a perpendicular from the reference point or the pivot point on the line of action of the force. This is your D. Now you can write down what I've just said, that F is equal to force and D is equal to perpendicular drawn from the reference point on the line of action of the force. Now, moment gives turning effect, no doubt in that. Now, we know that to represent a quantity properly, we should give the magnitude and the unit. But in case of moment, we should mention 3 things: magnitude, unit, and sense of rotation. So, unit is F into D, that means Newton into meter in SI units. And then sense of rotation, it can be clockwise or anti-clockwise. So if we see any clockwise movement, we will use this sign. We won't write clockwise. It is better if we use this sign. And if it is anti-clockwise, we use this sign. Now, how to understand the sense of rotation? I always mention that take the arrowhead and bring the arrowhead to the reference point in the shortest path. Take the arrowhead, bring the arrowhead to the reference point in the shortest path. I'm taking the arrowhead. I am bringing the arrowhead to the reference point in shortest path. So this is clockwise. Now you can say that this is also, but this is not the shortest path. I have to bring the arrowhead to the reference point in shortest path. That will give you the sense of rotation, guys. Now, let us start with now we can see a simple example here. You can see a force whose magnitude is 6 Newton here, and you have a reference point A, and this length is given 2 meter, and this direction is making 30-degree angle with this force. Now you are asked to find the moment about A. How to find that? Now, moment about A means I have to multiply 6, the magnitude of the force, with D. And what is D? You know that. You have to draw a perpendicular from the reference point on the line of action of the force. Is this the perpendicular? Obviously not. So if I draw a perpendicular from the reference point on the line of action of the force, this is the perpendicular, guys, the blue one in your screen. Now, this is your D. How to find this D? This is a right angle triangle. This is the right angle. This is the hypotenuse. So D would be what? 2 sine 30, as this is the opposite. We learned these things in our mechanics. Now, D is equal to 2 sine 30. So I have got the D here. So 6 into 2 sine 30. So this is the value that we will get by using the calculator. So that is the moment actually. So it is 6 Newton, guys. Now, how to represent the answer? We'll write 6 Newton meter. And what would be the sense of rotation? Take the arrowhead, bring the arrowhead to the reference point in the shortest path. It would be like this. So that means anti-clockwise. So it would be anti-clockwise moment. Hope you have understood this example, guys. Now, let us go to the next example now. This is a force, this is a reference point, and you are asked to find the moment about A. How to find that? Moment about A means the magnitude of the force 20 into the perpendicular drawn from the reference point on the line of action of the force. This is the line of action of the force. This is the reference point. So there is no perpendicular. 0. So if I try to draw a perpendicular from A on this line, not possible because they are collinear. The point and the line of action of the force are collinear. So the distance is 0. That means the moment is 0. So we have to understand a very, very important theory. That is, if the line of action of the force passes through the reference point or the pivot point, we can say it creates 0 moment. No moment is created. No turning effect is created. So this is a very, very important theory, I must say, that you must memorize or remember. So let us start solving this sum, guys. What is the difference between the previous 2 sums and this? In those sums, you have only one force. Here, you have more than one force. So when more than one force, you will have a combination of clockwise moments and anti-clockwise moments. So first of all, to distinguish clockwise moments and anti-clockwise moments, we have to take one sense of rotation as positive. It is up to you. But usually what we do, we take the clockwise moment as positive. But if any one of you thinks that I would take the anti-clockwise moment as positive, no problem, guys, you can do that. Here, I will do the sums by taking the clockwise moment as positive. Now, I have written like this. What does it mean? I have written moment about A and then this sense of rotation. This is moment about A and this is the sense of rotation. By mentioning this, I am trying to say that I am taking the clockwise moment as positive. So with this symbol, you will understand that I am taking the clockwise moment as positive and I'm taking moment about A. This is my reference point. Now, when you will be finding the moment about A, first of all, you should understand the sense of rotation. Take this arrowhead, bring it to the reference point in the shortest path, anti-clockwise. Take the reference point, bring it to the reference point in the shortest path, clockwise. So here 10 Newton will give you clockwise, 8 Newton will give you anti-clockwise. So let us start with 10 Newton, 10 into. How to find the D? This is the reference point. Perpendicular drawn from the reference point on the line of action of the force. So this is 1 meter. So 10 into 1. That's it. Now, this is anti-clockwise. So I'll put a minus sign because I have taken the clockwise sense of rotation as positive. Now, if I have to take the perpendicular distance from the reference point on the line of action of 8 Newton force, this is the perpendicular, guys. Now, what is the value of D? This is the triangle. Hypotenuse is 1. So D would be 1 sine 60. So D would be 1 sine 60. So this is your D, guys. So I would write minus 8 into D. 8 into 1 sine 60. Now, please use your calculator and keep the calculator in degree mode, guys. So you will find 3.07 and positive. Now, what is the significance of this positive value of this net moment or resultant moment? Positive means you took the clockwise sense of rotation as positive. Now the answer is positive. That means the whole system will move clockwise. If the answer would come negative, that would mean the system would rotate anti-clockwise. So this is the significance of this sign here. Now, how I will represent my answer? I will mention this value, 3.07. I will write down the unit, Newton meter, and I will write down the net sense of rotation. How would I get the net sense of rotation? By looking at this sign. If it is positive, then sense of rotation is positive. Net sense of rotation is positive. So it would be clockwise. So this is your answer, guys. This is the solution of this sum. Now, I will try to discuss this sum to you. Look at this sum, guys. This diagram shows sets of forces acting on a light rod. Very important. What did I say? Whenever you will be mentioned light rod, that means no weight of the rod should be considered. It is negligible. In each case, calculate the resultant moment about P. So this is my reference point now. So I will find moment about P, and I have taken the clockwise sense of rotation as positive. Now, this is your P. Now try to separate the clockwise moments and anti-clockwise moments. Now, take the arrowhead, bring it to the reference point in the shortest path, clockwise, this one. Clockwise. So these two are clockwise. These two are clockwise, and this one anti-clockwise. This one anti-clockwise. So 2 and 1 clockwise. So let us start with 2. Here, your task would be a bit easier because forces are perpendicular to the rod. Now, if I have to say 2 Newton, how to find the D? This is the reference point. This is the line of action of the force. You have to draw the perpendicular. So what is the length of this perpendicular? 1. 1. So 2 into 1. Now, we can do it very easily because the forces are perpendicular to the rod. How? Force is acting at this point. This is the reference point. Just take the distance. Take the distance along the rod. That will give you the answer. Now, then another clockwise is this 1 plus 1 into 1 is acting at this point. This is the reference point. What is the distance? 1. So it will be 1. Now come to the anti-clockwise movements. That is, I should put a minus sign for that. Minus 3 into, this is 3. 3 is acting here. This is the reference point. What is the distance? 2 meter. Now this 2 is acting here. This is the reference point. What is the distance? 2. So this is the net moment, guys. Now what we have to do is take your calculator and get the value. So the value is minus 7 Newton meter. What does it mean? The negative sign signifies that it is not clockwise. The net moment is anti-clockwise. It will rotate like this. So I would write the answer like this. Answer, it is 7 Newton meter anti-clockwise. So this is a very short lecture of today's topic because after understanding these concepts, you have to practice a lot of diagrams so that we can proceed with the next topics here. Because if you are not strong enough with these concepts, it would be very difficult for you to understand the sums in our next lectures. So do practice a lot from the worksheet. Then we will come back with our next lecture, guys. Thank you very much.